Hell yeah. Well, thank you all for coming post-lunch to our talk, Stealer Crossing New Horizons. I hope, by the way, so this is loosely themed around Animal Crossing, but I was informed that not everyone knows that game, so if you don't know Animal Crossing, just think it's cute island theme instead. So I'm Alden. I am a senior detection engineer at Huntress. I mainly work on the Mac product, but love malware of all types. And I am presenting with...
I'm Stuart. Wow, that's so loud. I'm a principal product researcher at Huntress, so help finding new threats, building out the roadmap, and I'm the resident millennial on stage, as you can tell by the tie in that photo.
So quick agenda, we're going to run through like what are stealers really, really quickly, just give like general gist of what they're looking for, where they're coming from, sort of what they do, and then we're going to jump into some RE. So we're going to run through all like the big e-crimey stealers and talk about all their quirks and features, and then finish it up with some like light detection related stuff to how you can catch stealers.
So let's quickly talk about what stealers are and why we should care. Quickly addressing the elephant in the room. Yes, we're doing a talk about stealers, similar to how you saw it this morning. Yes, we're also getting sick of looking at stealers, but we do think it's still important.
So we're kind of like segmenting like who we're looking at into like two little islands here. Right island is like the standard like e-crime commodity stuff that you can like purchase malware as a service. There's way more than what we're featuring here. These are just the ones that we figured are like, or the ones that are like flooding your VT feeds and probably making your RE life less exciting than you'd wish it was. But then DPRK is like the like APT side of the house that like writes a lot of stealer type malware. We're not going to touch on them too much, but they have one honorable mention. So yeah, like our focus is mainly just going to be these four. We're going to cover like AMOS, Poseidon, Cthulhu, and then Banshee / whatever Banshee became.
So when we talk about what they're after, it's pretty straightforward. They're after your information, and of course, that also means your crypto. They love going for your crypto wallets, whether it's your Bitcoin or Ethereum, whatever it is. And then, of course, your credentials. They are trying to get your password, your user password on your machine, and also your keychain passwords. So grabbing all the passwords out of your keychain, your browser information like your cookies, and then in some instances, they also try to grab raw files off of the endpoint. So whether it's your documents, downloads, or other things.
So when we were trying to figure out like how to like best show like the impact of stealers, we were like, we could just tell people that it steals stuff. But then we came across like a bunch of leaked stealer dumps, and we were like, it'd be way more, it'd be way more impactful if we could actually show like real like victim data. So we found a bunch of dumps because like infostealers are super leaky and their like stolen files end up all over the place, VirusTotal, Telegram, whatever. And so this is just like a quick zip file that gets like sent off from the host from, I think it was AMOS. But it contains like a bunch of files that have all sorts of juicy information.
Yeah, they're aiming for your user information, so they use System Profiler to dump things like your serial number, model, OS version. They will get your IP address, the city you live in, country, some other information. You can see that on the left. And then on the right, they actually just grab a bunch of logins, users, and passwords from your browsers. So you can see here someone's porn information all got hacked here, and exfilled. Additionally, they're looking for cookies. So they look in browsers like Brave, Chrome, Firefox, and they also go through the different profiles. So you might have a work profile and a personal profile, and they will actually go through and grab the cookies from those separate profiles and save them off. And then also they dump your keychain, which you can see on the right. We've removed some of it, but they try to grab all the information out of your keychain as well.
So what are the other caveats we wanted to like put out there before we get started was that like these are all like tools, and we're like personifying them, which I realize is now confusing, but like they're not like individual actors per se. Like the people using them are just like criminals, 14-year-old Serbian kids. Like it's just like not, you know, try to like separate them in your head as we're talking through them. The other thing is like, why do infostealers actually matter? I think a lot of times people just think that it's like for, you know, it doesn't really have impact for like business or whatever. But for like initial access, they're really, really scary because if your corp machine gets popped, then there you go, like all your Okta's gone, your VPN creds, and that's like prime for initial access for ransomware or whoever else is looking to get into your corp. And that's aside from like just losing all your money and having to change all 5,000 of your passwords.
So when we talk about where they're coming from, we've seen instances where it's cracked applications, whether someone trying to download something for free, and actually on the right you can see the autofills text file that the infostealer is grabbing off the endpoint to exfil, and you can see some history there, like someone searching for Lightroom for Mac. If you even go to the top, you see Adobe Universal Patcher, which is probably how they got popped in the first place. In addition to this, we see poison search results, so fake downloaders for other software as well, and then direct messages.
Yeah, people love DMing you, being like, hey, I have a hot new crypto project that I need help with. Can you download my code and run it and help me? And then you end up not having a fun game to play anymore, and you're sad because you have no money.
And we've seen this in the past. Jamf released a blog some time ago about Arc. So the browser Arc, a fake Arc installer, was packaged with crypto. infostealer, crypto. And we saw it happen with a fake homebrew as well.
This is like one of my favorite ones because I'm like, when I looked at it, I was like, oh shit, like this would definitely get me if I was like in a rush to install homebrew on my computer. Because like it looked completely identical. Like the curl command was basically the same. It actually looks a little more legit than the real one, which is just like a random gist link. But what the script actually does is it like yoinks your password and then curl installs malware, and you don't end up with homebrew, sadly. I think this is really poetic. This was another autofill example that we found where someone was searching for like, what browser is good for web dev? And then the last search is how to install an app on my Mac. Damn.
So we're going to dive into some RE, and we're going to start with Poseidon, who is one of the most well-known, and you'll see a common thread running through this talk with something we're going to bring up with Poseidon's story. So a user named Rodrigo4 on XSS released something, a stealer that was dubbed RodStealer, and then was rebranded to called Poseidon in September of last year, and this was strictly a marketing move. He thought it sounded cooler. The unique thing about it is they primarily used AppleScript almost exclusively to do all the cred stealing and dumping of information. They moved to a Python implementation earlier this year and then developed a nicer looking web panel, looked to target VPN configs during this last summer. And then only a month later, there was a big announcement that Poseidon was going to be for sale. So as I mentioned, it's very much just AppleScript. This is pretty much the entire binary here. It's pretty small. It's about 240K. And the whole stealer functionality is actually done in AppleScript. And the primary portion of this is base 32 encoded. And so if you just decode the base 32, you actually get the entire AppleScript, and you can just do this in CyberChef. And one of the unique things about it is we have our C2 listed here. And one of the more, I would say, trademarks of Poseidon is its use of P2P here in the path. And for writing signatures and things like that, this is an interesting spot to key on to start.
Yeah, the issue with all these stealers is that they're like really incestuous in their code base. So like you really struggle to figure out like who's actually doing what. And so like the C2 infrastructure is like your best bet for figuring it out, because like panels will live there. They always have like their own paths that they like, or the APIs are designed a certain way. So yeah, it's like the best way to sort of gut check what you're looking at.
So if we decode that blob, we actually just have this pile of AppleScript, and you can see the different things it's trying to do: getting your password, trying to grab certain files, picture files, documents, text, and then exfilling them at the end.
I will say, I think this is like the most complete AppleScript program I've ever seen. So yeah, as we mentioned, they did move into a Python version for like a little bit. It didn't last for super long, but it was funny because they actually bothered to like not just base 32 encode it. They tried to do encryption well. So it was supposed to be like a multi-byte XOR encryption scheme, but they didn't realize that you have to like shift the key over for it to actually work like that. So it ends up just being hex 60 is the key, which is kind of nice. So like a little quick binge script, you can dump the actual plain text Python scripts from the blob of XOR encrypted data, and then you end up with this really chat GPT looking Python script. It's basically like verbatim the same as the AppleScript version. Like the function names are the same, all the variables are the exact same, and it does the exact same stuff as the OSIScript version. It's just written in Python because I don't know. So as we said earlier, like panels are like your best friend when it comes to like attribution. And in this case, like Poseidon, they put a lot of effort into making it pretty and usable and having good like hacker experience, I guess. You can use it for like everything from generating new builds to searching your stolen content. You can like configure your malware that you have deployed elsewhere. You can like convert, they have like cookie converter helpers. So like your stolen data, you can like make it into a usable form. This is what the panel looks like when you like log in and you can like start clicking around. It lets you set, like you can change the picture of your DMG. You can change the password prompt that appears. You can like request extra extensions. Any kind of customization you would want, I guess, for your malware. But the nice thing is that all of the code is on the front end. So like all of like the back-end authentication stuff, you can just like view and like view source, which is kind of awesome. And none of the routes are protected. So like you as an unauth user can just like hit the admin API endpoints directly, which is super nice from like figuring out like who's using malware. Not that I would ever do that. I didn't do that. It was in Minecraft. But you can just see that there's just like default users and stuff added in there and like panels that actually have like real users. You can see that hypothetically. But then as we said, like Poseidon sold his malware recently, but it's kind of a weird one because it didn't really go away. It just kind of flowed on, as we'll see in a minute. So hypothetically, gone off the island of e-crime. And we move on to Banshee.
So Banshee is another infostealer. They are more recent, so originally released as a C++ in July. They released then an Objective-C version in August, returned to C++, and then only a few weeks ago, the Objective-C build was leaked online. And one of the interesting things about this is almost all of the collection is native, so very little AppleScript as compared to Poseidon.
Which at this point is exciting. So.
And you can see there when they originally released Banshee, there weren't a lot of people who were super thrilled about the new infostealer.
Yeah, it was hilarious. Every single message he sent was just thumbs downs, angry faces, like not a good reception.
So within Banshee, they will set up they will try to find they will get your temp directory to put their AppleScript, which they will use to gather the user's password. And again, the primary use of the AppleScript in this case is for this prompt and a few other things. So they use that also to get documents and downloads, but that's about the extent of the AppleScript here. They collect your browsers like the other ones. Always interesting how Safari is never on here. You always see Chrome and Firefox and all the other ones, but never Safari. And then some other just general system recon using System Profiler and getting the password from the user. And it wouldn't be complete without trying to get your crypto as well. So you can see here they're looking for different crypto wallets on the system. And as I mentioned, they try to copy some of your files from documents and desktop using AppleScript. And you might have noticed earlier in the talk from CrowdStrike where they spoke about they turn the volume down. They do the same in this case where they turn the volume down so you don't hear the copy-paste sound that occurs. And then they reset it after the fact.
I also love that like you really don't have to do much work here when you're already in it. You can just like, it's all there. It's great.
Lastly, there are a couple helper functions. And similar to the Poseidon example, one of the pieces that we're kind of keen in on are C2s or URLs that we find within the binary. And in this case, this is how Banshee is getting the IP of the host. So it uses the free IP API and then /API/JSON there in the path to gather the IP address of the host.
Yeah, it might seem weird that we're like mentioning this, but we've had really good success with detections that like key on anything running like IP info, like any of those like IP getting sites, because like some legit apps do it, but it's like pretty rare, and it's usually a good key that something sus is going on. Oh yeah, and so they released the Objective-C version, which again felt a lot like they just copy pasted the C++ version into ChatGPT and were like, make this Objective-C. It's like not very good, implemented kind of poorly. But from like an RE perspective, it's also great because all the symbols are there. They didn't make any attempt to make it hard. It reads basically just like regular Objective-C, which I don't know if that's a dig at Objective-C being hard to read normally, or if it's a pro for Objective-C decompiling nicely. But in recent, like last month-ish, they moved back to a C++ version that actually has like a slightly more annoying obfuscation schema for strings. Essentially, it's like a macro thing that they're using for like every instance of a string. It will like smack in like a XOR encryption loop with like a generated key for each instance of a string. And it's kind of annoying to like automate the process of doing that, or like extracting those resources, because like the strings aren't living in const like for all the other samples we looked at. So you actually have to do a little more work. A workflow that I found that works really nicely is if you write like a YAR rule for the actual like code that does the encryption loop, you can find every instance within the binary using like this binary ninja plugin, and then it's really easy to pull out the information you actually care about. Which in this case, like the data is just in that little top section. The key is like that little hex string that just changes for every single instance of a string. But it's like pretty easy to like re-implement. This is like a verbatim implementation. I'm aware that this looks stupid, but like it's how they did it, so that's how I'm doing it. And you can see just like example decrypted strings. Nothing too shocking there, except they are using IPify instead of IPinfo. But oh yeah, as we mentioned, like the Objective-C one got leaked, which is funny because apparently it was a result of some drama from like months and months and months ago. So when it released, like, I don't know, I was kind of underwhelmed. Like looking through the dump, it was like 8 files, and I was like, you're charging $100K for this? Like I got in the wrong line of work. But yeah, you can see that like they basically just copy pasted the anti-debug stuff from like the first blog post you see when you Google like anti-debug on macOS, which is pretty funny, but I guess we all do that, sure. But yeah, then after that happened, the author got kind of nervy, I guess, that people were not happy. They've never been happy with them, but I guess they were extra unhappy now. And he said that sales are closed for the foreseeable future, and that if you want updates, you should subscribe to their Telegram channel. It's just weird to me, though, because like the Objective-C version, they weren't really using that anymore, so I don't quite understand why they would close down sales, considering the recent version was like actually kind of okay. But yeah, I don't know. So on to AMOS. This is like the OG. They were like the first ones that did it. They still do it, I think, the best, or like second best maybe after Cuckoo. So they've been real into just like trying everything and seeing what sticks. They've moved from like a Go binary in the start to a C++ version. They were like, oh, like this is getting SIG'd because the functions aren't encrypted, so we'll add some mangling in there. And they were like, oh, like this is too easy. So then they started doing like a bunch of just like junk code insertion. And then they like kept like adding weird new obfuscation. And then at one point they were like, oh, we'll download a Poison Ledger Live binary and just replace the one on disk with our version. And it was like, okay. This is like loosely, like I think V1, 2, 3, 4, 5. I don't know what they're at now, but it's just been a mess to follow. Unlike the second Go version, they just like slapped Garble onto it. It's the same code pretty much. It just is like slightly harder to RE. But now, in the last like 2 months, they've moved to I'm calling it FOSS, Free Open Source Stealer, because all it does, these binaries are just decrypting and running, you guessed it, the Poseidon Apple script. So basically all these binaries are just attempts to make detecting that like Apple script harder. So they've gone through like a bunch of stuff. They started with just like hex encoding the payload, which is like not like, okay, fine. Then they went to base 64. Then they went to base 64ing the base 64, and then base 32, because that's, no one uses that. And then they finally settled on actually trying encryption for a sec. So they were using RC4, which is good for them. They're figuring it out. But like the keys are static, and they're just like in the string section, so like it really doesn't take much to get the AppleScript payloads out. But you know, give them kudos for trying. But then the one they moved on to recently, which I was like kind of interested in, because it was actually resulting in pretty low detection rates. It was sitting at like 0 for a long time. They're still creeping up a little bit. I think they're still sitting mostly from like 5 to 8-ish on virus total. Not that that's like a great indicator, but like gives a little insight. But they've moved on to like a custom base 64 implementation. And I don't know how many REs in here have gotten the feeling of like REing code that like is just very standard, but you don't recognize the algo. That happened here, and so you all get to have the same pain that I did when I didn't realize that it was a base 64, basically. But what they do is they like build a lookup table based on like an alphabet that they supply randomly for each binary. And this lookup table gets used in like the actual, I think it's just basically standard base 64. So like the ordinal value of the alphabet, like they put like that index value in the lookup table at like the ordinal value times 4. And they do this for the whole alphabet. And then they have this like kind of gross implementation of it. I just did it verbatim. I'm sure you can do it with like a translate table in Python, but like this is like how they were doing it. So for the sake of example, but then you can see like the like run through of the script where it like looks up the character in the table, does all the bit shifty stuff, and then ends up with the OSA script payload coming out. But yeah, it's free OpenStealer again. Exciting. But the tell here is that the API is very different than all the Poseidon payloads. It's like their own thing. They're using like join system. They used to use sendlog, but they've moved on. Okay. So Cthulhu. Cthulhu is a weird one because they kind of negate the point I made earlier about how it's tools, not people. They were a Traffer group and an early AMOS client. This is a screenshot from like February of this year, where all of the like users in the AMOS builds were in plain text. And you can see that like Cthulhu team is one of the users. They had a lot of binaries. There's like an open, so they used to like supply open directories to like host malware. I guess because the sites had like good reputation or something. And you can see that like Cthulhu is a user directory. Like all the customers had their own directory, so it was cool. You could see everyone that was buying it. But yeah, so they forked-ish the original Go version. They added a bunch more functionality. They made it a little bit worse, but in their own special way. And they don't have a C2 or anything. They were just using like MongoDB, Amazon S3, like free file sharing sites to like store their files. But then, so like RE and Go obviously isn't fun, but then this got uploaded to VirusTotal, and my YAR rule hit on it. I was like, yes, yes. Wait, hopefully this means that I can like not have to RE this anymore. And sure enough, all this binary did was format string the Go source code with the user supplied credentials. And so we don't need to do any RE. We can just kind of like read the Go source now. And it's awesome. It's like 2,000 lines long. It's full of errors. They have tons of comments in there of like they were like, this shit isn't working. Which I'm glad to see that they suffer too. But they had like a developer kill switch in there, which I thought was neat. So like when they were like playing around with builds, they wouldn't infect themselves. Yeah, so I have that on my desk. They're my app folder now, just because, you never know. Then like the bottom left screenshot is like their C2 exfil stuff. We'll talk about it more on the next slide, but it's kind of funky. They have like a lot of different places data ends up going. And yeah, and like the rest of it is all just like standard Stealer stuff. Like they query the browser databases and all that jazz. So yeah, their exfil is kind of odd because they're using like these free file sites. And so basically they would like request a URL from these like free file sites, upload the stolen victim data there, and then send the link that they uploaded it to a MongoDB instance that was globally readable and writable. So you could just go like query all of their victim logs from the MongoDB instance, which made it pretty easy to figure out what was going on. So yeah, now it's just AMOS left on eCrime Island all by themselves.
We briefly wanted to mention RustDoor, which is the DPRK's infostealer. This was a cracked Visual Studio for Mac application, and inside of it contained a binary called ZSH-ENV, which again contained what looked very much like the Poseidon Apple script, yet again.
Support open source software, people.
One of the interesting things about this, there was a lot more interesting functionality, but one of the interesting things that you didn't see with the other infostealers was persistence in this case. So it would drop a launch agent in the user's library and would persist that way.
Yeah, this one did do a lot more cool stuff, and like there's like a couple thoughts I had about like why they put this in there. Maybe it was just that it worked well. Maybe they wanted it like be misattributed to like eCrime because someone saw this with like a Poseidon YAR rule and they were like, all right, it's not DPRK, it's something way more lame. I don't know, but either way, people need to get more original.
So it's mostly just AMOS and then DPRK. Yeah. So really briefly, I know time for this talk and this afternoon, but I wanted to briefly touch on the detections that you can implement to try to find this. And we're taking this in the context of behavioral-based detections, and think of it from an EDR perspective or whatever your favorite tool is to get insight into endpoint security API from Apple. And you can use a bunch of different tools that's not an EDR, like Apple ships ES Logger, there's ESF Playground, Brandon Dalton's Mac Monitor, Sprite Tree. There's a pile of tools that you can use to get insight into this. And if you've taken Jaren's training, some of this will look familiar, but when we key in on our process, our parent process, and then the grandparent process, this is a good way to kind of have an understanding of what the infostealer is doing. And in this case, we can see an application with a common infostealer name, TradingView, running from the mounted volumes. And that is a good indicator. And then, of course, it's spawning OSA script, and then that script is running do shell, which spawns sh-c. So you can use these different connections in the process tree to find these infostealers. And what that might look like to the user is that same pop-up that is asking for a password.
And like a lot of like the commands that we're showing here, like on their own aren't necessarily suspicious, but like in context of like other stuff is like pretty weird.
And knowing that app is helpful, the one in volumes, but a lot of times you won't know that, and it's mostly helpful during threat hunting or something like that. But if you don't have that information and you're just running a rule, you can key in on other things such as DSCL. These infostealers usually use it, or that Poseidon Apple script uses it to verify the credentials, and you can then use the arguments that are passed into it as well from endpoint security. And lastly, system profiler is super common. If you just run it from the command line, this is what the output looks like, and this is what gets put into that userinformation.txt file. And you can use something similar to this to look for that kind of command running, and we can drop that into something that'll show us a process tree, and we can see OSA script calling shell on the far left, and then sh-c and system profiler calling the other commands as well. And you can see that here in that base 32 decoded Apple script.
Yeah, so like a lot of those commands that we were talking about, they're all like nice because they always show up on the like VT sandbox stuff. So if you have like behavioral rules set up on there, it's like a good way to find anything kind of weird. So yeah, some like quick takeaways. Behavioral detections are your bestie here, considering that they're always just trying to like throw new obfuscation at their binaries, even if they're not doing anything super crazy like themselves, but the Apple script is all the same. So if you sig on those, like it doesn't matter what they put in front of it, it'll just end up hitting regardless. Remember that when you're looking at these, it doesn't really, the tools aren't the people. So like Rodrigo's not stealing your stuff. It's like, again, someone else. Just good for context if you're like in an IR or something, you don't like tell people the wrong thing. Stealers are an issue, despite them being boring and nobody wants to look at them anymore. Like, they cause a lot of issues and they can be really problematic. And yeah, they don't need to be actually good to be effective. Like, most of these that we talked through are like equivalent to like code sludge, so everyone's, but they work, and so they don't need to do anything cooler. So yeah. So we're gonna put a bunch of stuff in a GitHub repo. We're gonna make it unprivate in a second here. We have some Sigma rules for detections. We have config extractors for all of the families we talked about. We have some Yara rules, other like IOC listings and stuff like that. If y'all want like the Go source code for any of the stuff, let me know. I'm not putting that on GitHub because I don't want to see it again. But I'm happy to share it with researchers. So yeah, thank you.
Thank you.